So far, we have learned how TypeScript handles variables, types, and even how it infers and combines them using unions and intersections. Now it's time to take things to the next level. In this episode, we are diving into three powerful features that will help us organize our code better: functions, interfaces, and type aliases. Functions will show us how to make our code reusable and predictable by defining clear input and output types. Interfaces will help us structure complex data like objects in a clean, consistent way. And finally, type aliases will make our types easier to read, reuse, and maintain. By the end of this episode, you will see how these three features work together to make your TypeScript code more organized, flexible, and professional. All right, let's jump in and start with functions. As our programs get bigger, things can start to get messy really fast. Variables everywhere, repeated logic, and data structures that don't quite fit together. That is why TypeScript gives us tools to help organize and structure our code. Things like functions, interfaces, and type aliases. These aren't just fancy features, they're what help keep code clean, consistent, and easy to maintain. They let us do three powerful things. Number one is to reuse code, so we don't have to keep writing the same thing over and over again. Number two is avoid repetition, which reduces bugs and keeps our programs efficient. And communicate intent clearly, meaning anyone who reads your code immediately understands what it's supposed to do. So, in this part of the lesson, we will explore how these features help us write code that scales. Code that is not just working today, but also stays manageable tomorrow. Now let's talk about how TypeScript handles functions and specifically how it lets us describe what a function expects and what it gives back. In JavaScript, you can call a function with pretty much any kind of value. And if you make a mistake, you usually don't find out until it breaks at runtime. TypeScript fixes that by letting you declare function types. That means you can define exactly what kind of data your function takes in and what kind of data it returns. So, when you write a function, you're not just describing what it does, but you're also describing what it expects. This makes your code safer, clearer, and easier to understand, both for you and anyone else reading it later. Think of it as adding guardrails to your logic. TypeScript ensures that every call to your function follows the rules you have defined. Next up, let's talk about interfaces, one of TypeScript's most powerful tools for organizing data. An interface is basically a blueprint for an object. It tells TypeScript what properties an object should have and what types those properties should be. You can think of it like describing the shape of an object, not what the object does, but what it looks like. For example, if you're working with a user object, the interface will specify things like it must have a name, an email, and maybe an age. And each of those has its own type. The great things about interfaces is that they help your code stay consistent. If you forget a property, or spell one wrong, or use the wrong type, TypeScript will immediately catch it for you. So, in short, interfaces make your objects predictable, structured, and easy to work with, especially in larger projects where multiple files or developers are involved. Now, let's talk about another powerful feature in TypeScript: the type aliases. A type alias is like giving a nickname to a type. It lets you create a custom name for any type, whether it's something simple like a string or number, or something more complex like a combination of types. This is incredibly useful because it helps make your code cleaner, shorter, and easier to reuse. Instead of rewriting the same type structure multiple times, you can define it once, give it a name, and then use that name anywhere in your program. Type aliases are especially handy when you're dealing with complicated types, like unions, intersections, or nested objects. They make your code easier to read and maintain. especially when working in large projects with multiple files or team members. So, if interfaces describes the shape of your data, type aliases are about creating clear labels for the type you use most often. Now let's have to our code demo in order for you to understand all of the things that we have tackled so far. Now let's create a new file here in order for us to start. Let's say for example, this should be quick4.ts. And let's have first the concept of declaring function types. So again, the concept is that functions in TypeScript define what they expect, which are parameters, and what they return. So let's have a simple function here. You should have a function keyword, and then the name of the function. Let's say, let's put here add. It means that we are adding numbers for this function. Let's have an open and closing parenthesis. And this should contain the parameters or the data that it will receive. Parameters are the placeholders or just like a variable of your data inside the function. So let's have, for example, parameter A and parameter B. Now we will also put here a type on the parameter. Parameter A should contain a number, while parameter B should also contain a number. And then you need to declare here the type of what the function will return in case your function should return anything. Because there are functions that are not necessary to return something, but rather do some operation inside your code. But in this part, if you want to return something to the one who calls the specific function, like this one, which we will do later, we need to determine what will be the data type of the data that this function will return. Let's say, for example, it should return a number, and we will do the operation here. Let's have return, and let's add parameter A to parameter B, and it should return a number. Now, if we try to remove this or change this, for example, let's return cat or dog, you will obviously see that the error will come out. And it will say type string is not assignable to type number, which is what we have declared here. So we need to turn it back, A and B. Now, let's test if this parameter types really works. Let's call this function. So let's have a variable here to represent it. Let result equals to, we will call the function, just add, and we will provide the parameters. And the data that we will provide to the parameters are called arguments. So let's have here, for example, 10, and 10 will go into this parameter A, and the other one is 30. 30 will go to parameter B. Should be a comma, not a period. Okay, and then let's have a console.log, sub result here, and then let's compile tsc quick4.ts, and then it will create a new JavaScript, and let's have node quick4.js. So it is 40. Now, if I try to change this and make the number 10 a string by putting here a double quote and also the 30, you will notice that it will have an error. Argument of type string is not assignable to parameter of type number. So it is expecting a number, so you should also give here a number as an argument. Let's turn it back and let's move on to the next topic. Now let's talk about interfaces. So interfaces define what properties an object must have. So let's create an interface in this part. Let's have interface. Let's say, for example, this interface is named user. And what does a user should contain? A user should have a name, and we will declare it as string. And then age, we will declare it as number. Is admin, we will declare it as boolean for the true or false. Now, in order for you to create a new data referencing from this interface, you need to call it on your variable. Let's say, for example, let and say user1. Now we need to blueprint this interface here. Let's copy this. User equals to. Now we need to provide the data based from this blueprint. So let's have name as Alice. Let's have a comma, then age, it's 20. And let's have is admin, and let's say this is true. Now, if you try to add more data here, you will notice that you will have an error, and it will say object literal may only specify known properties, and salary does not exist in type. So therefore, what have you have declared in the interface should be the one that will reflect in user1. All right, so let's delete this to make this right. Now let's try another one. Let's say let user2, and let's use again the blueprint or the interface. And let's say, for example, name. If you try to change this to Bob, and then here age is 30, but here the is admin, we will try to change as string, let's say false. So the error will still come. Type string is not assignable to type boolean. Okay, so that's technically the idea of interface. Now, if you will ask the question, what is the difference of using interface versus just using a customized type, is that interfaces are open and can be extended or merged, just like what we are doing here, while types are closed once you have already defined the data inside of it. All right, so let's correct this data to move to the next sample code. Okay, so now for the last example, we are going to type aliases or the custom type names. Actually, you have done this on a previous episode. I will show you. So if you will remember, we have declared here a type, and this is already an alias because it's a customized name and not the built-in types inside TypeScript. But for the sake of those who did not watch the last episode, we will still do it. So let's have an example. So you can customize a type inside TypeScript. Let's say, for example, type, and let's say the type is a player, and a player could contain different properties. Let's say, for example, gamer name, and the property should be string. And then let's say, for example, label, and should be a number. Okay. So this type is named player, and you will notice that player is not a built-in data type inside TypeScript. Now you can use this by having the declaration of the data itself. So let's say, for example, let user player, and you will have here the player type, and you should declare the value. So it should have a gamer name, let's say Allen, and it should also have a label, which should be a number, let's say 400. So that is what you call type alias, and type aliases make your code more readable and let you reuse types easily. Thank you for watching Quick Chain Lessons by Chain Academy. If you want to access more courses, please visit our website at www.chain-academy.io.